Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, I'm Nick.
Hello, I'm Ed.
Hey, I'm John.
And, this week we got, John back with us. And the first thing I want to do is kind of delve back into last week's topic before we kind of, knock out this week's topic. And what we talked about last week, we got into the New Year's new tech resolutions. So something that you want to learn, something you want to see, possibly something you want to attend. So what are you trying to do as far as the tech space, to learn or attend or be part of, or all three of them or above?
Yeah, I mean,
this year.
That's a hard one. There's a lot of stuff because, honestly, it's
intentionally meant to be that way.
It's weird as my ADHD taking me this week. So one of the biggest things that I've been kind of looking at is some of the costs at the house of keeping lights on, keeping doors open, efficiency stuff, right? So for me, there's a lot of opportunity in my house for I would say IoT topics and kind of getting into something IoT based. So I've already purchased the ESP32 or something like that. I think that's the model. And I'm gonna start with the garage, making the garage Wi-Fi and being able to tell if I left my garage door open at work or something like that.
Oh, there you go.
These are things that I've not learned how to code or learn how to do just yet. So these are topics I would like to do. I've got an Arduino now, or a few of them actually, and some components. And kind of like, I think Ed, you've talked about it before, one of those like build your way through something. Those things are pretty fun, but it's also good because it'll teach me some of those little things that like mechanically that I haven't learned because I haven't progressed through or haven't had the time to learn. I did like basic circuitry in college, but we barely touched diodes. It was mostly just we very quickly got into like and or gates, logic gates, and then that was kind of where it kind of stopped. So it's just like, this is how computing works, and I would like to know a little bit more of that. So that's kind of like what I would like to learn or kind of do, project based, starting with kind of smart home. But place I want to event I want to go to, I'm going to Automate. That's one of the most that and Rapid were two of the most interesting events. Unfortunately, financial constrictions will kind of limit some things, and California is a little bit further away than Chicago, so going to Chicago,
we'll play the ping pong game next year, I guess.
Yeah, we'll figure. I mean, honestly, it's going to take time, and you do have to devote a lot of time to some of these things, and sometimes you don't have as much vacation time, you don't have as much to cover costs and things like that. So things happen, but Automate's going to be a great show. They're going to have a lot of the robotics like manufacturers. I think probably the KUKA guys, Siemens is probably going to be out there and things like that. What was it, like over 300? Yeah, Yaskawa. So a lot of that side of the house we'll be able to see. Whereas we went to Rapid last year and we saw a lot of the additive manufacturing push, and kind of you could see all of the directions that certain companies went in, whether it's like super large prints or super like the most micro prints that they can make. We saw that on both sides. So I think that I expect great things out of Automate, and I expect things much like that. Like we even saw a system at Rapid for I think it was Orbital.
Orbital E.
Yeah, where they had a Delta system with multiple KUKA robots. Like that's crazy to see. And honestly, it's a similar venue, but across the hall, right?
Yeah, we're across
the
street.
Bigger, it's a bigger building. I'm assuming. I believe, right? So I expect like
we were on West Side last time. We're going to be East Side this time, upstairs on the second floor.
I expect there to be a much more grandiose like scale of a show, big giant machines and robots now, and not just that, like people just being able to automate things. Period. I mean, it's kind of in the name, like your controls and automation side of a lot of the houses there. So to me, it'll be nice to see that side, because the only part that I've ever kind of been in is being the IT side and going out onto the floor and saying, hey, this is what I see. What's happening?
Yep.
So
and hopefully this year, when we get you out there to Chicago, we can actually see the training panel that Yaskawa has, and get your hands on with that, so you can actually see what me and Ed were talking about.
That'd be
That's just absolutely revolutionary when it comes down to robot training.
Yeah, that'd be cool. I mean, honestly, a lot of this, if it's even just based on robotics, like training and you know, safety, even and just getting how the robots work in the nitty gritty of it. Like, I would like to see any demonstrations. I'm gonna go right up to most likely. So you get like we're probably gonna have to have several times where we will be kind of squirrel off and kind of get distracted because there's so many places we won't get to see all of them.
And one good thing about the difference between Automate and Rapid is Rapid was 3 days. It was a 3-day show. Automate's a 4-day show.
Yeah,
So it's Monday to Thursday.
An extra day.
So you have a little bit more time. They go till 7 o'clock almost every night, unless we go see a football baseball game. Then it's kind of out the world on that one.
Yeah, it depends.
So
they usually. I mean, last time they closed at 5. I'm assuming they're going to close at a reasonable time, and then we can go see a game. But yeah, no, it's nice. I mean, we went to Chicago. It's just it's a nice area. I mean, to be honest with you. It's a great convention center. We had a lot of great food, so I'm honestly very excited just to go back. Yeah, just seeing any of the robotics that's going to be something that I look forward to pretty much the most of the year.
Yeah, it'll be fun.
Yeah,
and which glad you're able to let us know because you weren't here last week with us. You had some stuff you got to get done, but this week. We're going to kind of dive into, a little bit more into the 3D printing side of the house or the additive manufacturing side. I guess we really should stop calling it 3D printing and go to additive manufacturing at this point. But it's, the medical prints and stuff like that. So, we're talking about, hip replacements. You're talking about jawbone replacements. Stuff we saw at Rapid. You're talking about, the resin dental printers.
Yeah.
That type of stuff.
Yeah.
And... It's, what is it? Brain the covers for somebody has to have cranial surgery or something.
Well, yeah, no. So that you don't have to have a steel plate in your brain
right.
or in your head anymore. You can have a 3D printed, implant. I mean, to be honest with you, medical printing, it could be so many different things. It doesn't have to be like those are the first things you think about, like medical, like how is this piece going to be implemented into a person to help medically get them back to fully functional or something like that.
Yeah.
I mean, so actually implanting something, I think is much more of an invasive, and we can get to that a little bit too. But I'm like the first thing I think of whenever someone says medical printing, I was even like, okay, so what can I print that assists a current medical practice?
Okay.
Right? What can I print that would it would be a material that takes the place of another tool that, like, you think about, it's a medical place.
It's like
a hospital has to be very clean, right? So they have, in that case, they have a lot of disposables and things like that. So it kind of sucks. If you take away having everybody have to constantly get new disposable items and you're just making the things new. I mean, honestly, if you're making them in a clean room and now they're sterile, right? So that's the type of thing that I'm thinking of, and even something as simple as a cast.
Yeah.
Because when you go to the doctor now, when you get a cast, they wrap your arm with some cloth. The problem with that being, how long is it going to be on there? Like a couple months. You're probably gonna sweat. You might get hot. It might be summer. I mean, you have you're gonna take a shower. You're gonna have this cast all over your arm in the shower. No, it's gonna break and then fall off, right?
Right.
So at the end of the day, the problem with the cast is conventionally is moisture and things like that. Well, what happens with plastic when it gets wet?
Yeah, it just beads off.
It's fine. Yeah, it's something that you can develop. A cast in such a way that it'll keep your bone held.
Yeah, like a splint.
Yeah, like a splint. Now, I feel like bigger breaks would be a little bit tougher to kind of maintain. Like if you if you break a couple of your bones in your leg, you're not going to wear a splint for that. You're going to need something.
But if you think about it, if you print it in TPU or a flexible nylon, for example, and you're able to roll it up, secure with a zip tie. You can actually throw that into a firefighter's bag, and so they have a portable splint, just in case they need one. And you can make multiples of those. And the thing is because you can do honeycomb shape, you know, based on using TPU and stuff like that, and it still holds its strength, you know, even being a little bit more squishy.
Because that's what
you're reducing the carry weight of the of the rescue personnel.
Yeah.
And you know the thing is ounces equal pounds, pounds equal pain. You know, it's something that we were taught very much so in the Marine Corps is, you know, you determine your fate by how much you're going to put in your pack, and before we go for a long walk.
How much you get attached to items.
Right, exactly. So how much water do you need to drink to get rid of it before you get to the other end?
So I just to follow up on what both you guys talking about, I think the biggest is 3 areas. You know, basically you can do implants and prosthetics. It's one area that's right now being implemented. Other areas are anatomical models, and then, like you said, medical equipment. So if we start with just the implants and the prosthetics, if we look at it from a logistics point of view, we're looking at like musculoskeletal injuries, and basically with those, like you said, they're doing things for like replacements for bones. Some of the stuff with bone replacement, like you said, they're doing stuff with the jaws. They're doing stuff with dentures and so forth. But
kneecaps.
There is a cartilage.
Yeah, cartilage.
They're 3D printed.
Yeah, because you used to have to put screws in the bone, but now you could probably just
a little bit of TPU.
Yeah.
But Enable is a group that's a volunteer group that has over 8,000 3D prints that you can print right now for prosthetic type things.
Oh, okay.
So that's one thing. And like I said, then we can get into the anatomical models. You know, now a person doesn't necessarily have to have a cadaver.
Yeah.
And you can probably print things. And I forget the guy that made the German museum where he sliced the people up and took them apart where you could see the inside of the person. You wouldn't have to have something of that magnitude. You could actually 3D print out just the heart and have it as a model that you could take apart, put together, or you could have it as a functioning model where you could do something low tech to have it working. And then like there are also things where they're printing stuff for respirator type things in the medical devices. I think it's less than $10 worth of material.
Yeah, no, it's incredible. I mean, to be honest with you, that's it just makes sense that we would be going there. And when you think about it, they've been using like 3D technology, 3D scanning and things like that already, like your MRIs and things like that. So they like it. To me, the medical field is one of the most, I would say, advanced fields in a lot of the
scanning technology.
Yeah, and in the research that goes into the medical field is able to get to such a point where they're able to test some of these things as well. But like you're absolutely right, because that was going to be something that I thought about when I was like first going to the dentist and your parents like pull you out of school, make you go. You're like, I don't want to do this, and they tell you they poke and stab at your gums and stuff like that. But then they're like, hey, this is your annual checkup. We're going to do a model of your teeth. You absolutely get in a machine, you bite down on something, and they scan your jaw, and they take and make a like clay model of your jawline. So that was one of the first times now that I think about it that's additive manufacturing right there, unless they did some type of CNC machining, which I don't think they did. So to me, like additive's been around a while, and medical has been accepting it. So I think that it makes sense to kind of touch on this. But Nano Dimension was one of the companies that we saw that was able to print on such a scale and have it still workable. So dental implants, like if it's like cosmetic implants, I think in most cases there's going to be a place that can do this for you now.
And the thing is we're finally coming out of the Stone Age when it comes down to medical printing. We're moving out of the archaic world of everything needs to be cast and then poured and you have to wait. If you think about it, you got these guys out there who they get medical insoles because they're either flat-footed or something like that, and they have to wait 3 to 6 weeks for these custom-made orthotics to show up. Why? Why can't I just throw it in a model and just print it? If you're printing nylon, it really doesn't matter. The weight, it will be able to take it, and because of the spread. But so it's like you still get sometimes where I think it's certain portions of the medical field that are a little bit more archaic than others.
Yeah.
As far as they're not, really jumping in on the bandwagon, while some others are. You have the guys who are doing your therapies, who are embracing that type of stuff because they're embracing the fact that they can print their own tools and or get their tools CNC'd or something like that. And I watched Titans of CNC, and one of his guys was in a car accident, and he made a CNC piece of stainless for his trainers that helped break up scar tissue. But the thing is, he CNC'd that. However, you can still take one of those things and throw it in a freaking in a laser sintering device and print it that way too. Yeah. If you didn't want to throw it through and print it in stainless steel instead of CNCing it, which each his own. But I think finally, with the advent of the shows like Rapid and the organizations like SME out there who are bringing this stuff to people's attention and saying, "Hey, guess what, guys? You can do this. It's a little bit different, but we'll get there." And it's like you have a couple other companies out there that are specializing just in Forum Labs, for example. Don't know why I almost forgot that name. The fellows over at Forum Labs, the stuff that they're doing with their resin printers right now is absolutely ridiculous.
They're huge into the medical. They've actually had a couple like presentations on YouTube they have about medical printing too. So they're Forum Labs is a good one to listen to.
It's a good case study.
Yeah, no, they have a lot of good information. So, that's the truth. I mean, like when you're thinking medical printing, like most people aren't. They hear that and they're like, you're printing like hearts and lungs and stuff like that. In certain cases, I mean, yes, but that's not going to be a functional lung right now. But I can guarantee you that at a certain point that they're going to attempt to try to print something like that and get it to work. I have no doubt that they're going to continuously push the bounds and maybe not put it in a person immediately, but like think about what happened. What did Neuralink do the other day? They put a chip in someone's brain and they're reading signals from it. There was I don't know if it was Neuralink, but there was another company that connected someone who was a paraplegic to a kind of like a 6-dolph tiny little KUKA robot, little one of those things, and it was like fist bumping Obama or something like that. Like that was crazy to see. I was absolutely wowed by something like that. But the fact that you could probably get to some type of implant that's 3D printed that could maybe fit in some type of module or something like that is incredible. I mean, it's a little scary, and sometimes people are already scared of microplastics. I get it.
Well, if you think about it, they've got to the point now where they're 3D printing tissue.
Yeah, that's the thing. I mean,
they were printing tissue on the International Space Station. Right?
Yeah, so it's like the soft fabric tissue.
Yeah.
Okay.
So I think that the measure for like anything that people say, hey, this is new technology, is has it become a microwave yet? So what that means is it an appliance that's used in hospitals? So as of 2019. There are 113 hospitals that have centralized 3D facilities.
There you go.
On site.
It's growing.
Yeah, but that speaks volumes. Before it was only 2 or 3.
I think it's what matches out somewhere about a quarter of the United States.
Yeah.
At this point.
So I'm just saying that it is a technology or a type of tool that they're using now.
And the thing is if you think about it, Roll 3. What we call Roll 3, when I was in the Marine Corps, is Roll 3 trauma hospitals. They are ones that could benefit from having a 3D printing lab on site. Your trauma environment, that's what you do. You handle all of the major accidents in your area. They show up at your front doorstep. If you can have printers on site where it's like, hey, I need to stabilize this guy or gal or something like that who's got a broken arm, let me go ahead and print this splint real quick to fit him, just so I can triage this guy a little faster before I move on to the next. The thing is more and more and more you see Roll 3 or trauma hospitals get involved, I think you'll start seeing where, a lot of that comes to light because, some of the big wigs and, the trauma hospitals are always looking for ways to speed up the triage process so you're not sitting in the ER for, 3 or 4 hours at a time.
Yeah, I mean, not even just that. Training practices. Like, you have a 3D printing facility where you don't have to have somebody's, like, heart is, like, lacerated and you're trying to come help do some type of surgery or something like that. Or I don't know exactly. That sounds a little bit ridiculous, but, like, you don't have necessarily the same examples, like, in front of you that you could 3D print. Like, if someone broke a bone or a piece is out of place, how do I pop these back into place?
Right.
Like, things like that, as well as knowing this is something that, like, I was thinking about the other day, is if you can scan someone, like, with some type of MRI or CT scan, right? CT's for your brain, I think, actually.
Yes.
So MRI, you scan any portion of your body, but if you can create, like, someone's stomach, and then you're like, hey, this is the size of their stomach, okay, this is the amount of medicine that would be able to metastasize or whatever you want to, or whatever it's called in the stomach. You're able to digest this much, so you don't over prescribe dosages and stuff like that. If people are taking certain type of medication, you can judge if someone's like, hey, this is the size of their stomach, or this is the size of the person, and that doctor's supposed to give you some type of medical, like, medication, like prescription. They can better make judgments off of those things. I mean, it's training. I mean, that's just a small example, or a small, like, one example out of
and most of your large hospitals have medical artistry departments in them.
Yeah.
So you got it's like and also the medical schools have have medical artistry departments. That's all they do. They draw this stuff out. They're part of the lab work guys. That stuff, you get those guys involved in making CAD models and STLs, and they're printing, especially if you get like a bamboo lab, or you get like a some of the other a Voron with an enraged carrot feeder kit on it. So the thing is you start doing multi-material, so you can actually start printing realistic hearts. So you can actively print these things out, give it to a student, and say, hey, guess what? You gotta go. You're getting to cardiology. Here, you can study the heart, and you actually have something to hold on to. And you can easily make it, removable, and have like the valves, and have everything labeled, because guess what? You can print it in multiple, colors. You can print, the veins in blue. You can print all this stuff, the outside of the chambers in white, and with a red lining and stuff like that. So you can still print all of that, and it gives a student, a cardiology student, something to hold on to, stare at, and go, okay, cool, I know what I'm looking at now.
Yeah.
And then
some people hands-on learners, yeah.
Yeah, another application is so I know everybody's seen their grandmothers Monday through Sunday peel containers. So poly peel is something they're working on now, where a person taking 5 or more doses of medication, where you have each of the levels in this poly pig that dissolve at a certain rate, and you can customize the dosage of the medicine. So that's something they're looking at with 3D printing also, where they're making personalized or specialized pills, where a person doesn't have to take 5 pills, because they have to have this medication after heart surgery or some type of transplant. So this pill would release at certain intervals. So that's another avenue that they're doing stuff.
Sense.
It's crazy how much chemistry is mixed into not only just what you're printing out of, but like what the end product of the print is too.
That goes a lot with a kind of. I think you and me had the conversation when we were walking around the floor at Rapid, especially when we were going between like Nano Dimension and Polyspectre and a couple other guys. I think the conversation came up about what's next in the world of filament and resins. I think that's a conversation that I think you and me were having part of that conversation. I think we were talking to a couple of folks from Forum Labs about it too. It's like, what's next? What can be next?
Yeah, the Forum Labs was doing the flame resistant FDM, and they also, I think they have a flame resistant resin too. We saw Fosen had like impact resistant. To be honest with you, everybody's trying something different. So I think that it makes sense. And if you can have something, this is something that I think we should cover in a future episode or something like that, because there's a lot that we can kind of unpack. But like a dynamic print or something like that that's able to change over time. I mean, that kind of goes into like if they're using 3D printing for those pills. I mean, that's dynamic if it's changing or taking longer, like time release.
The rate that the membrane dissolves.
Yeah,
so they're
exactly.
printing multiple membranes, and I'm not sure. I'll take a guess. Not saying that this right. Depending on the thickness of how you print the membrane compared to the acid in your stomach, it would have some rate of dissolving that membrane. I'm guessing, may not be that.
I wouldn't
but
doubt
just
that
a
it's
guess.
also something with the lattices or the structure too. So,
Could be. Yeah.
Now, if you think about it, something like that, if you know how most people, you talk about the plates people have installed, if they break a bone or something like that, you can use 3D printing if they can come up with this safe enough for like a dissolvable plate that as the bones fuse together and finally grow together, that plate slowly but surely dissolves. Because now
bone graft or something.
Right. Because the problem is right now what you have is you got these people getting these plates put in their foot or in their arm or leg or whatever. They have to go back and have it removed. Where they're stuck with this plate there, and you walk through the metal detector, sounding like you freaking, you're smuggling something. And next thing you know it, you're in a back room and it's quiet, and somebody's put on gloves. It's you don't want that.
I don't want that.
You're
not gonna find anything.
And I would go a little bit further where you're going with that. Let's just take a little further. So
what direction are you going on?
One of the last things that
no.
we were excited about just 10 years ago was nanotechnology.
Yep.
Nanomachines. If nanomachines is a thing that we can make happen, and these nanomachines can be distributed throughout the body to do repairs, why couldn't we deploy nanomachines with 3D printing capability to make these lattices inside for the bone grafting?
Yeah,
Why could that capability? Of course, I don't think we have the computing capability for that now, or we haven't got things down
Small
to that
enough.
structure. But if just 10 years ago, like I said, that's something everybody was excited about.
And that, I'd see a benefit in it, and then for some certain reason, one that popped in my head is Magic School Bus.
You're gonna shrink, right? I mean, that's so. It does, It doesn't seem like it's too far off. To be honest with you, it doesn't seem like it's too far off. I mean, some people are gonna have to. Yeah, right. Some people are gonna have to fight off the kind of fear of like letting tiny little robots like go into you or something like that, or work on you. But like I think at a certain point, once everything's proven and starts working like it should, like it's going to be undeniable. I mean, I wouldn't doubt that that's something that would happen.
I would even argue that what you're talking about, that generation is probably in the next 50 years won't be here.
It's fair, yeah.
That generation that you're talking about has those type of concerns. Was it the book 1984? I think it is, where it talks about things that are happening in the future. We've seen some of those things come true based on what this guy wrote. Years ago.
Yeah.
But that I don't think you're going to have a problem with that because technology has become so ingrained in the youth of the day. I don't think you'd have any resistance. I think the issue is they can probably make it in a lab, viable, but making it do what it's supposed to do in the body. So, for example, if the newest thing, and not to get off, I'm just going to do a real quick AI and machine learning and blah, blah, blah. Yes, it's fantastic. Yes, it's wonderful. Yes, it can change the world. The problem is still you cannot take the human brain as of yet and take all of the functionality that the human brains and all of the processes that go with, sending signals here and there. AI at this moment cannot do that. Plus, it does not have, I would say it doesn't have a soul. And not to get in religion, but I mean, it doesn't have substance. It's not real. I'm not going to say it's not real intelligent. It's artificial intelligence.
Right.
Yeah.
Exactly,
It's
artificial
exactly- yeah.
intelligence.
Yeah.
It's like
It's trying to emulate
It's
it,
trying
but
to
it doesn't-
emulate
it's
something
missing-
that it can't at this
Right.
moment.
and it feels artificial.
They used
Yeah.
AI to fly a fighter jet against an actual fighter pilot. The only problem is they had to terminate the test because the AI airplane doesn't have the thought of death and was actually spearing instead of shooting. It was going to spear the other pilot.
Which would work.
It would work.
Yeah.
But the thing is
Didn't think that.
it's,
I mean, that's a couple of $1 million, but
Right.
Probably
who's
couple
fussing about a
billion.
few million
so
dollars?
they terminated the test, but they said the funny part is because this thing didn't show any fear. It saw them coming from a long distance away, and then immediately went to an engagement pattern.
Mm-hmm.
And immediately went on the attack without waiting.
Mm.
So you had that stuff out there. You also have the drones that are flying around whatever.
Yeah.
But that's here nor there. That's
Like I said,
that's
not to take us down the rabbit hole. We're not saying it's good or bad. I'm just saying
right.
that
It's there.
getting back on topic with the nano
Yeah.
technology being somehow incorporated with the 3D printing technology, where it could print, structure, tissue or bone material or cartilage or whatever. Even maybe even can do repairs to blood vessels. Who knows?
Yeah.
We've already seen it where it's being used in an expeditionary pattern with the Marine Corps and the Navy, printing out friggin' casts and stuff like that,
Yeah.
splints for people who are injured, printing on the back of a helicopter.
Man, can you imagine what that would mean to a country that is not does not have the economic means
Yeah.
to have all of the equipment you have to have
Yeah.
for something as simple as a broken wrist?
The thing is
They're just gonna get a couple sticks.
and it's really been a thought process for me. It's when I've been thinking about it, is how can 3D printing impact third world countries and stuff like that. How can we see that improve?
Other than putting stuff in the ocean.
Yeah.
Yeah.
But
But yeah, okay.
the thing is with that you get the guys, you get the 3D printers that are doing splints and stuff like that.
Yeah.
You have concrete 3D printers building hospitals.
Exactly.
And you slowly but surely build the infrastructure. You're building things
Right.
from these 3D printers and going bigger and bigger and bigger until sustainable life happens.
And you don't have to have specialized training. So I don't have to have a architect on site because I have a model that's been used, and I put the model in there. I allow the printer to go. I have to make sure that the printer follow the parameters. We don't have anything like clogs and things like that. But that's a real short training, and that third world country, like you said, now can become self-reliant.
Right, exactly. The thing is I think for them,
More resources. Yeah.
they're the ones who need the help the most. It's like if you think about it, at that point, because the thing is one big thing that you have with medical is the fact that you need clean water. If you can 3D print the tubes and stuff like that you can make siphons, you can make cleaning tubes. Just 3D printing a tube and stuffing it full of freaking charcoal. And you've just made a way to make potable water.
I mean, if we go with the lattices, like John is talking about, why couldn't we have lattices that's based on carbon,
Like carbon filtering.
that's built into this
Yeah.
thing we're printing, and we don't have to add another process.
Yeah,
all in one process.
Yeah.
You get exactly what you're saying.
And the thing is I know there's some resin prints out there that can actually do carbon filament, and that can pull carbon and stuff like that out of water. But the thing is, if you think about it, that is able to make even the smallest of countries freaking viable because now they have clean drinking water. They're able to print those things and hand them out. So their medical facilities become more and more and more valuable based on the influx. Yes, power may become an issue, but if they're in an area where power isn't very much generated, unless you're trying to run an entire 3D printer off of a sundial.
Well, I mean, I think there are things that you can do.
Yeah.
Even in those
Generators, yes.
Yeah, generators. You can do things with, like solar power in conjunction with some type of battery technology that's, not, I would say invasive. Even if you couldn't use that, you can There are other things you can use like wind power to use generating electricity. So I think it could be done because we're not saying that this thing has to run 24/7.
Right.
But at least I'm able to take this machine out, even if I had to run petrol, which is probably not ideal.
Yeah.
But even if I had to put petrol in this printer, and I took this printer on site, and it did what it does, heavy equipment runs all the time.
Yeah.
So if we can do heavy equipment, I'm pretty sure we can take the same concept that we use for heavy equipment and quickly apply it
Diesel
to a
powered
3D printing application.
Yeah.
That's the same way.
Diesel power 3D printer.
We can basically have rentals where you can rent this machine that has the capability to 3D print a house.
Disaster recovery. You know, you start dealing with disaster recovery at that point. And the thing is their first thing to do disaster recovery is you focus on the medical fields. You know, get them up and running before you focus on everybody else. Because if the medical's moving, then you can triage whoever else you find.
And here's one other thing, like we was talking about. Okay, maybe the nanobots is not something that's viable at this moment, but dissolvable materials are. If we can have the same concept of a poly peel, why can we not have a structure that we're using for bone grafts or whatever that at the end of 3 months, 6 months, it dissolves.
Yeah.
It lasts for this amount of time, and it's beyond the amount of time that the heal has to happen. Or let's say we add some technology to it. Hey, we add some microprocessor, and we can do it. You can make microprocessors as small as you want to, like even almost the size of a grain of salt. And you can use, maybe some of the things that happen in the body to power this device, or you can maybe add some where the blood flows, say blood is flowing across it, and it has some type of generator that allows it to flow and create a small enough power where you can communicate back to the doctor, and it tells the doctor, hey, it has healed. So it's just a sensor to say, hey, the fracture is healed. Hey, it's my birth date is due or up, and the doctor sends a command to say, okay, start the process of dissolving, or just say so many months.
Yeah.
Dissolving.
Yeah.
Oh, that's definitely
It's probably going to start there, to be honest with you.
Yeah, I'm just
So
saying,
many
like,
months,
it's countless ways of doing it, but for me, what I would like to see, and it's a little off, I would like to see for the plastics and microplastics that we generate have a way to do exactly what we just said. I would like to see one day we make biodegradable plastics. But still,
100%.
without losing the properties of having those,
Yeah.
the characteristics we have. All those
Sacrificing
things
quality.
I don't want to sacrifice quality. I think it's a way to do it. Maybe it costs more to process, but I think if we can do that, then 3D printing would really be a win-win.
This is what I was getting into. It's the chemistry where you're really like you get into the nitty gritty of the atoms and how and what elements are connecting and things like that. Because some of these are non-dissolvable just because of the materials, like the bonds that are created are so strong that you need a lot more and more energy to be able to break them and things like that. So for them to be able to dissolve, it's almost impossible. So but PLA dissolves biodegradable.
Yep, it is.
So I think that you're not wrong in the sense that like it's going to happen, because Polyspectra was another company that we saw at Rapid that was developing some resins that were high impact resistant, as well as they had like tensile strength, like the like if you print a bridge, you try to snap it in half, it takes a lot more foot pounds to break, more force, as well as a finished print. They could put in some boiling water, and what do you do? What happens usually with a print when you get it back to the temperature that it was printing at? It gets back into this little muck or this goo or whatever, and it starts being malleable again. However, with their prints, no, they were fine.
Solid the entire time.
Still solid, yeah. Still, I think it was the test print for Anycubic, that little cube.
Yep.
And they were doing fine. So it's gonna be
We gotta get them on here one of these days. with it.
Yeah, it's gonna be a breakthrough in the chemistry. It's gotta have to be. It's gonna have to be a breakthrough of how the print is done, because another company that was doing some cool stuff was I can't remember their name, but they make the shoe with Adidas.
The sole.
They make the 44. Yeah, they
44.
So they have a way that it's not only, there's two ways that it's curing, and it's they're spinning it and getting all the excess. They're hitting it with UV, and they're hitting it with temp. So there's two ways that it's curing. So that makes it that much more durable, right? So that's a company, that was their materials company, and that's kind of what their specialty was, is developing things like that. Just from his explanation on the YouTube video that I saw about it, if all the researchers think like he does, they're gonna figure it out.
Yeah. Well, I think right now it doesn't make dollar and cents.
That's it.
I don't think the research
we
is
run on a
put
dollar
into it, because why would I change PET, or why would I change ABS, or why would I change nylon? Why would I change this process? And nothing to do with 3D printing, just in general, plastic injection molding. Why?
Yeah.
Why would I add more cost?
And if you think about it, there are companies out there who we have seen that fishy filaments that make filament out of
they're like a pure reclamation almost.
Old freaking fishing line.
Yeah, I remember you was telling about that. Yeah.
So there's that. There's always that.
And that's recycling is a big part of it, but so 3D printing is not the biggest abuser in the landfill. By that, so anybody that's pushing that's incorrect. That's wrong.
Right.
It's consumers are the biggest impact.
And
additive is inherently better, just because you're only adding as much as you need.
And the thing is, if you think about it, then you start to get a lot into like what you were talking about earlier, the hospital waste. Once you can start knocking out that hospital waste a little bit, you think about how much trash they generate.
Yeah. Or cruise ship, or like I said, it's really us consumers. Think about how much plastic you're putting in the landfill every week.
Yep.
You're putting in a plastic bag that you put the material in. You have containers that have plastics in them. You use body wash that has plastics. And on and on and on. Restaurants that have plastic. Not trying to condemn anybody. I'm just making people realize that we are the we are the people that are making the demand.
If you think about it, I saw something the other day, and it is done in an additive way, is the fact that there are people out there that are making, like, for example, for like hospitals and stuff like that, utensils and plates and stuff like that out of baking soda, out of compressed baking soda.
Yeah, that's pretty cool.
It doesn't transfer any flavor or anything like that, so people can still use it as a plate and a fork and all the other fun stuff. But as soon as you throw it away, it's gone.
But here's a novel idea. What if we just had metal utensils? How long would a metal utensil last?
Yeah.
I'll be honest, it'll last a long time.
But the thing is, you think about how many one-use plastics they use in hospitals.
I was saying, just say, not anything I'm using for surgical.
Right.
I'm saying,
food and stuff like that.
and then I'll get us back on topic. Then I'm saying, just food in general. If we had metal utensils, and they had, some type of system that sanitized that utensil, millions of dollars would be saved in the food industry. Yeah. Millions. Your cost would plummet.
The cafes that they have in Europe, you have where you put your plate and your bowl and stuff like that in the carousel.
Yeah.
And stuff like that. And they don't use any one-use plastics anymore. It's everything's cleanable. You do have your napkins that you're throwing away. So really, you're throwing away your napkins in a recyclable can. Other than that, everything else is washed.
And if you're using IoT, and we'll get in some of these topics in later episodes, but if you're using IoT, like some of the Japanese airports, where basically the disposal unit presses down the trash, compacts it each time, and then when it's ready to be empty, it sends a message to somebody. Then they come pick it up. So you don't have to have a person that runs around and do a routine. Yeah. It tells you.
Yeah, I don't think we're far off from that, to be honest with you, because that's how, I mean, when I worked in Boston, that's how their compactors were working in the city, because it's so tight. You had to be on such a tight schedule.
Yeah, I think they got them in Atlanta Airport too.
Yeah, it's only, I wouldn't say everywhere, but only in certain places are like this. I mean, where it makes sense, of course. So yeah, I mean, all these things, medical based, like to me, it's still, even though lots of hospitals are using it, I still think it's in its infancy as far as 3D printing is
only
concerned.
113. How many hospitals are in just South Carolina?
Yeah, a lot.
We have what, 4 major roll 3 triage?
I'm just saying, just think about how many are in a state.
But yeah, you think about probably all the major ones have the 3D facility, right? So for me, like the fact that they're implementing it and they're creating like a space for it, it's good, because that's gonna only, you know, it's gonna only create more of the demand that we're talking about, the need, or at least prove the worthfulness of it. I don't know if many urgent care centers are having it, but
none probably.
Well, I would like for us. I know we're getting close. We're getting a little long on the episode, so we'll probably get close to ending, unless you guys want to add some more things.
I was wrapping up anyway.
But I would like to add this. I would like for us to come back to this topic after we cover some other things. But I would like to cover it from maybe we do a little bit more. Hey, it could be used, as you said, in a triage application. Like you said, it can be used for, hey, we need to make some kind of cast or do bone grafting or skin grafting. And then also for kids that don't have money to 3D print their own prosthetics. I would like to come back sometime in the future where we kind of delve into that and say what the advantage of that is, and maybe offer some avenues for people to get access to these models, so they can start, maybe looking at them and playing around with them.
Yeah. And I think with that, we've kind of came towards, kind of rounded it out and came towards the end. Of course, I always wanted to, say thank you. We're at, 2,206 all-time downloads. We've kind of, been making waves and, moving finally, getting the waves underneath us. We couldn't be happier, to share this with y'all. Definitely, go check out some of the stuff we got going on. Printed Heritage, we got stuff going on over there. We'll have more stuff going on the blog soon. We are going to be kind of really starting also getting into discussing how to STEM 3D printing and stuff like that impact the automotive aftermarket. We start dealing with that. Be ready. We're gonna have some fun with it. You'll definitely get some coverage from Automate this year. So I want to say thank you, and I'm going to turn you over to the guys.
I'd just like to say we appreciate all of the support. We're looking forward to bringing you more content. If you guys have any ideas, or we want to probably set up a poll sometime in the future to get a vote on how do we want to do a live version of this? Do we want to maybe have a Q&A? Do we want to have a meet and greet? So we want to probably offer a few options to you guys and do a vote and see what the people vote on, and then go with, what the majority says, and maybe we'll do some fun things like that.
Yeah. Happy hour live stream.
Yeah. And from my side, of course, I say thank you. I mean, it's every single time. It's nice to have an avenue to at least talk about some of this stuff. But if you guys have not, you should check out some scholarly articles. If you guys have not started learning on something, or you've heard something that you were like, hey, I don't know enough about that, go on to a couple of those. You can Google scholarly articles online. There's free directories and free databases. A couple of them, JSTOR and DOAJ. I'm going to be honest with you. I don't know what those mean exactly, but one of them is Department of Open Access Journals. I think that's the last one there. I mean, so pretty much every time someone submits something to get approved with their school, they're probably in some type of research program. They submit it, and then they ask if it's done well enough, or ask to get submitted to these open posts. So it's something that you guys should check out. It's something that I've been kind of digging into and looking at, and you never know what someone's working on until you read. Like, I'm not saying you got to read like 20, 30-page articles, but there's a couple cliff notes that you can see and get your mind thinking, So check out a couple of those. But stay tuned. We got a lot of stuff coming, and get you on the next one.
All right, y'all. Have a good one.
Have a good one.
All right. That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanar Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.